Yes, hope all of us are doing fine. My name is Ernest, and this is Ernest Sciences and Mathematics TV channel. In my discussion today, I'd like to welcome members to the concept of limits and asymptotic curves. And this is going to be assisting us try to interpret some of their applications, especially on the concept of L'Hopital's rule, which is going to be assisting us define various forms of what we refer to as indeterminate forms of functions. Now, in this specific case, we're going to consider a case whereby we're going to have this specific distance between what we can refer to or a distance from a wall. So we're going to have this specific, of course, set as our wall given as such. And there's a distance between the wall and a particular point which we're going to give in terms of perhaps P. So if we have a distance between P and the wall given in terms of S. So if we try to halve or divide this specific distance into two equal parts given as such, we are going to see that at this specific point, perhaps we're going to have a point of a P prime. And if we do a subsequent division for the two sides towards the center of towards the direction of the wall, we're going to see that we're going to have another point, perhaps a P prime prime. And if this specific excess is repeatedly done for each subsequent half of this distance from the wall done as such, we're going to see that we're going to have a range of values whereby we're going to have this specific, of course, distance from the wall divided into half. And of course, as we are going to see that we're not going to come close to the wall, since this specific distance is going to be continually being divided as such. And of course, we're going to see that however close we may come to the wall, there is still going to be a separation distance between the wall and this specific point of P prime, which we're going to be dividing. Now, in a sense, this is going to be giving us a concept of a limit, since the wall is going to be a particular point which we're not going to come across, and therefore it's going to be forming what we refer to as our limit. This is because this specific point, basically the wall which we have given as such, will never be reached. So in a sense, we're going to be approaching this specific wall by subsequently doing a division of this specific distance by half, but it will never be reached. So in a sense, if we have this specific W, then W is going to be forming what we refer to as our limit. And we're going to look at this specific concept of a limit from this particular example for what I've given as a wall. And therefore, if we have a function which we're going to define in terms of y is equivalent to x plus 1, so we can evaluate this specific limit by considering, of course, the value of x as it approaches a particular value. So if we have the limit as x approaches a particular value of 2 for the function of x plus 1, we're going to see that we can evaluate the limit of this specific function, which is going to be basically a value that we're going to have this particular x substituted for 2 plus 1, which is going to be giving us basically a value of 3. So in this particular case, we're going to consider this specific 3, but basically as a wall that we have already defined, that however close we may come, we are not going to be achieving this specific value of 3, but it's going to be forming what we refer to as our limit. So we're going to see that as well, whenever we're going to define this specific limit, whether it's going to be existing, the value for the specific limit on this particular set, which we have given, of course, under the left-hand side, must be the same, whereby we're going to consider that if we are going to have a point that we're going to approach given as such, if we consider from the left-hand side and the right-hand side, then therefore this is going to be forming our value for this specific value of 3, which you have achieved for this specific limit. And therefore the value for the right hand side and the left hand side for this specific function for what we have just defined as a limit for this function is going to be the same. Now in that specific case, then therefore we can say that this specific limit exists. And we're going to consider different forms of this specific limit, which are going to be referred to as, or different applications of this specific limit, which are going to be referred to as indeterminate forms, which can be given, of course, in different range of forms. So these are going to be particularly the indeterminate forms, which are going to be, of course, of different values, which we're going to consider for this specific limits. So these are going to be appearing in the forms of this particular representation, and of course which are going to be following expressions which we are going to give in terms of this particular value. So this is going to be given as infinity over infinity given as such. These expressions are going to be appearing in the form of 0 all over 0. And of course, we're going to particularly perhaps take another one, which is a negative infinity over infinity given as such. And these are going to be some of the indeterminate forms which we're going to come across, especially in our discussion of units. Now, the limits. Now, I mentioned the concept of L'Hopital's rule, and we're going to see its specific implication on the concept of these limits as we're going to do different evaluations. And this specific wording which I've just used for the concept of indeterminate means basically that these are going to be values or some things which are going to be regarded as without values, or in a sense, or literally we're going to have them regarded as meaningless. So this is going to be meaningless given as such. For instance, if we have a value which has been given in terms of y is equivalent to 1 over, of course, x, where x is equivalent to 0, then we're going to see that this specific value is going to be having literally no meaning for us, and therefore we're going to see that this is going to be, or rather this is going to be basically be given as which of course a value which cannot be determined unless we attach a condition to this specific value, and this cannot be determined if this specific value of x is equivalent to 0. So in this case, this particular aspect of the concept of indeterminate, we can literally borrow it from this specific function, which we are going to see that basically they are going to bear this specific significance that indeterminate form means without values or meaningless. But from the various laws which we are going to come across, we're going to see how we can treat such a kind of functions. So kindly check out description boxes for various links of other videos. Engage us in the comment section and also ring that notification bell for other updates on different discussion in math and sciences. So that is it for now, guys. Bye. God bless you. Catch us in our next video.